to lesson 4 on measures of dispersion. What does dispersion mean? It means how spread out something is. We also call these measures variability, measures of variability. So we're going to use those two words interchangeably. Dispersion means how dispersed out the scores are. Variability means how the scores are different from one another. And these are all ways of describing a set of scores. So I'm going to talk with you about the relationship between central tendency and these measures of dispersion. We'll talk about an explanation for score variability, and then 3 types of dispersion measures. So when we think about central tendency, it is that point that describes the central point of the distribution. So if you take a look at this wheel on the right, the center part right there is where the center of the distribution is, let's just say. And we use words like mean, median, and mode to describe the most typical score in a distribution, or where most of the scores tend to be, the most representative score. Dispersion, on the other hand, talks about how scores are distributed around that central point. So think of it as the spokes on this wheel, how the scores are arranged around that center point. And together, these are the two primary values, central tendency and measures of dispersion, that are used to describe a distribution of scores. So this measure of dispersion is a descriptive statistic. It talks about how closely the scores are clustered together or how spread out the scores are. So in a small population dispersion, the scores are very tightly clustered together. So that's sort of this, on the right, the taller peak there represents a distribution where the scores are all pretty close together around the mean. And there is not as much variability, there's not as much dispersion. But when we have large population dispersion, that means that the scores are widely spread out, and that's represented by the flatter curve here on the right, when the scores are more different from one another. So in addition to being a way of just describing data, we also use measures of dispersion in inferential statistics. We do this when we're determining how accurately a sample represents its population. So if you'll remember, sampling error is the difference between the sample that we drew and the population that it came from. So this is an example of how our score varies from what should be the mean. So measures of dispersion are range, variance, and standard deviation. And they each have their pluses and minuses. Let's start with the range. The range is the simplest description of a spread of scores. And basically all you do is you take the lowest score value and you subtract it from the highest score value. This describes the extreme scores in a distribution, but it says nothing about the scores that are in between. So it's simple, that's a benefit to this measure of dispersion, but it lacks in some of the information that it provides. So let's take a look. We have 2 different groups of scores here, Group A and Group B. And you can see very easily that they both are going to have the same range. Group A, the range is 8. How did I get that range? I took the highest score value of 10, I minus the lowest score value of 2, and I came up with 8. But lo and behold, the same is true for B. But let's take a look at how these scores would look graphed out. Wow, they look really different, don't they? So for Group A, that's more of a rectangular distribution, which means that the scores are highly variable from one to the other. They run the whole gamut. But in Group B, you can see that most of the scores cluster between 5 and 7, and some of them are outliers. So this is the same range of scores. They each have the range of 8, but it really doesn't describe how the scores vary from the mean or how the scores cluster around the mean. So that's why we're going to need a different type of measure of dispersion. And so in the next video, we're going to talk about something called population variance. I'll see you there.